Hey everyone, morning. My name is Eric Lee. I'm a first-year MBA student at MIT Sloan, and I'm here to present our workshop series at the 2019 Sloan Sports Analytics Conference brought to you by Rakuten. So it's my pleasure to introduce our presenter for today, Asma Toomey, who is the editor-in-chief at Hockey Graphs, and she's here to present the workshop using R for predictive analytics.
Hi, thank you for having me. I'm very honored to be here. I'd just like to start by saying this is a workshop intended for beginners, so people who are new to analytics and programming in general. So I hope this will be a good use of your time, and if not, I would totally not be offended if you have to step out. So thank you. So my workshop today will be R for predictive modeling. I'm Asma Toomey. I'm the editor-in-chief of Hockey Graphs. So our goals for today will be to review the basics of linear regression, and then we'll be fitting a multiple linear regression model using R to predict player points. And finally, in that process, we'll be visualizing our results in our model as we go along. So what is regression? So regression is used to predict a response variable, also called outcome-dependent variable, from one or more predictor variables, which are also called the explanatory independent variables. Regression analysis does three things. First, it identifies the predictor variables. Second, it describes the form of those relationships. And thirdly, it provides an equation to predict the response variable from the predictor variables. So right here is a table with the main types of regression. Today we'll be specifically fitting a multiple linear model, which the typical use of it is predicting a quantitative response variable from two or more explanatory variables. And the first four belong in the family of ordinary least squares regression, which in that, a quantitative dependent variable is predicted from a weighted sum of predictor variables, and the weights are parameters estimated from the data. So here is a slide just going a little bit through the math of the OLS regression. And here again, our goal is to be selecting model parameters that minimize the difference between actual response values and those predicted by the model. We'll see live what that looks like. Specifically, they will be selected to minimize the sum of squared residuals. So to properly interpret the coefficients of the OLS model, we must satisfy the following assumptions: normality, independence, linearity, and I will not try to pronounce that last one. So here, just differences between simple and multilinear. Again, we'll be doing a multiple linear one. That's when the regression model contains one response variable and more than one predictor variable. We'll actually also be doing a simple linear regression to begin with just one predictor. So let's start. I recently tweeted the files that I will need everyone to be downloading on their computers if you're participating. So I'll let everyone do that for a little bit, and I'll check in with you guys in about 3 minutes. Is everyone finding those okay, by the way? Yeah. Can I please get a show of hands of whoever's ready to go? Great. So we'll start. So first off, for people unfamiliar with R, one of the first things you're going to want to do is install the packages you'll be using. So today we'll be using dplyr and ggplot2. So if you already have those installed, please feel free to go directly to the load packages. If not, this is what you do. You sort of highlight the line and then you press run. So if your installation is complete, please feel free to load the packages into your session by, again, highlighting and just pressing run. And next in R, what you're going to want to do is import your data sets. There are many ways to accomplish this. One of my favorite ways is just to literally pull my data sets from my downloads file. And what I also like to do is name the data frame to something pretty intuitive that you'll be able to easily recall. So for me, since we're working with power play, even strength, penalty kill, and all situations data, I just went ahead and appended that with original. And the check names portion of that basically just tells R not to get rid of any strange characters in the column names. So with that being said, let's go ahead and import all of our data sets. Mine are all imported already, but we can do that now. And next up, we're going to just do some little exploration into our data sets, make sure everything's looking good, so we can go ahead and run the head, which will just give us like the first few things. You can check the size with this one, and looks like we have 29 variables in our all situations data set with 2,889 rows. Column names is also a really good one, just to check what we've got. And another thing is you can also look at just like a very specific subset of your data frame by specifying the rows and the columns. So right here, we're just looking at the very first columns and very first rows with that one. And next, we're going to be doing data cleaning steps, which is arguably the most tedious part of it all. A lot of people do like to do their data cleaning in Excel, but I find R to be very powerful in its capabilities of cleaning and just making sure everything is organized. And when you're doing multiple data cleaning steps or running multiple models, you're going to want to keep track of all the data frames you end up creating, and so that's really where R shines, in my opinion. And so, so the first thing we're going to do is make a copy of the all situations data frame, because we're going to be making some tweaks here and there. So I've called it X. Again, you want to keep the names of your data sets very, very short and straightforward, because you'll be using them multiple times. So you should see X appearing in your environment with the correct dimensionality. Next, we're going to be getting rid of some problematic characters. So R doesn't tend to do too well with like spaces or percentages or periods and stuff like that. So let's run that and make sure those do not appear in our cleaned data set. Great. Next, we're going to preface all of the variables that change with all to not have duplicate column names, because eventually we're going to create a big monster one with like all of our data sets. So we want to keep everything straight. And in this command line, so we're going to want to leave all the first 4 columns unchanged because they stay constant. Again, these are like team, season, player names. And then the end col portion of it tells us the number of columns there are in total, so it's also the number of the last column. So it's basically saying, okay, just keep the first 4 unchanged and 5 onwards will change. So let's run that. And then we can check the column names and make sure we did that correctly. So yeah, it looks like that worked. And so because we've only done that for our all situations data set, we need to be doing these cleaning steps for all of the other ones. And this is where, again, R is really good because we can just create a function and save ourselves a bunch of time instead of having to copy and paste and do it for each data set. So just highlight the whole portion or whatever you want. You can just also just put your cursor right there and press run. And when that's done, you can assign the clean data frames to new shorter names for use in merging, which will be the next step. Okay, so now we're ready to merge everything. We're going to merge them into a big data frame, which we'll call total. For those of you who are familiar with SQL, the all x true portion of it means we'll be doing a left join. So first, in the first line, we're merging the all situations data set with the power play, and then the second one will be taking that and adding on even strength, and then the third one will be taking our total and then adding on the penalty kill data. So next we're gonna inspect that everything's looking good. Again, we're just gonna run the col names total, make sure our columns are looking good, and we have everything. So it looks like all situations of the first few, and power play, and penalty kill, and even strength. Okay, great. And then we're going to take a look at our data set with the summary command line. I specified the first 15 just to keep things pretty brief, but this is a really, really good way to check the distributions that you have in your data set. And next we're gonna be lagging. So lag columns have data from previous years, and this is important because that's essentially what we're gonna be using to predict the current year. So first, right here, we're grouping by player, and then we're creating new columns by applying the lag function to all the variables 3 times. And right here, what we're doing is filtering by time on ice. So for even strength, I chose 400 minutes as the cutoff for inclusion, but you feel free to use any cutoff you'd like. So let's run that. again, I think I'm starting to sound like a broken record, but we're going to again inspect and just make sure the dimensionality and everything's looking good. Great, and so now we're going to get a glimpse of our data set, this time with visualizations. It's an excellent way to do some exploratory analysis and figure out what the next step should be. So first we're gonna just construct a very basic histogram, one variable, which is points in all situations. Great thing about ggplot2, that this is very basic, but you can very much customize this graph, add a title, add a legend, and so on. But let's just keep things simple. This is the sort of things you'll be doing for yourself, just to look at the distributions and your data. And next, let's do a scatter plot. So let's look at even strength points versus power play points and see what that looks like. And now we're going to get to the modeling part. So first, just one predictor. Let's keep it simple. The first step that I like to do is make a smaller data frames with just the variables of interest. Given that we're only looking at one predictor, that'll just be all situation points. That's just an approach I'd like to take, but you can also just pull directly from the total big data frame. Let's run that. And once that data frame is ready, let's go ahead and fit our model, see what we get. And then summary model, that's when you'll see the results. So for this part, I'd like to call your attention on the R squared, which is about 0.54. So that means we've done a reasonably well job of predicting points. We have at least a little more than half the variance explained with our model just using one predictor. So let's go ahead and visualize that, because visualizing is always better than just staring at a table or results. And yeah, so again, pretty good. Pretty confident in that trend line. And so thinking of the next few steps, maybe the player position does have an impact on points. So first off, let's just look at, because position is a categorical variable, we're going to want to see what kind of categories we have with that. In hockey, because players sometimes play center, they play left wing, they play right wing, we want to make sure that everything is segmented very cleanly in either being a forward or a defenseman, and not have categories are like CCL or something like that, which some hockey websites do have. So yeah, it's looking all good, only 2 categories. So we can go ahead and fit our second model with more predictors this time. So because primary assists are considered to be more repeatable, then we'll just add that as a predictor, and we'll also add shots for, that's the ICF, and position, and let's see what we get. So first off, again, we're making a smaller data frame with just the variables that we want, and next we're gonna run the model, and then summary again to see what's going on. Okay, so looks like I'll call your attention again on the R squared value. It seems like our second model has definitely done a better job at predicting. And next, we're going to be looking at our model residuals. These are differences between the actual values and the predicted values from our model. And a great way to take a look at that is, again, using visualization to see this. So it looks like all of them are pretty clustered around 0, which is good. This is what we want. And then because this was like a viz way to look at it, we can also look at it in a different way. This will let us like glean which players were the biggest surprises, whether positive or negative. So let's take a look. So that'll be all for our portion of the presentation. I hope you found that to be useful to you, and I will include a cleaner version of this code with like more in-depth explanations of every step. So please look out for that on my Twitter. And let's just go back to our presentation for a little bit. So it doesn't end there, right? If you remember this slide, an important part of modeling is to always check your assumptions and make sure you're satisfying all of them or as many of them. And when you're doing these sort of models, you want to test your assumptions and have regression diagnostic tests also to validate it. And future directions. So our models were very, very simple. You want to start thinking about what important variables have we left out. Could we have used rate statistics instead of just points, things like that. And we also haven't used one significant predictor of a player's point, which is age. And that's obviously a big one too. And we used an inclusion cutoff of 400 minutes. When you're building a model, you're also going to want to see like how your results change based on things that you specify, whether it's like cutoff of minutes or cutoff of really anything. And that'll be that. Thank you very much.